Hello, my name is Simon Spurrier and I am the Engineering Systems Manager responsible for the Engineering Systems portion of the presentation to the Engineering Discipline Leads. When presenting the Engineering Systems portion of the Discipline Leads training, I focus on the support role of Engineering Systems, followed by an overview of how the engineering discipline tools we are using are developing towards data-centric applications. I start with the role of Engineering Systems and how this fits in with information technology and the information management groups, outlining the roles and responsibilities of each. At this point, I focus on the input required from the leads to determine what their software and licensing requirements are. I reinforce the notion that the person who wants a new piece of software working through the discipline lead is the best person to drive the software request which goes to Global IT for procurement. As we move into the presentation of the software tools, local circumstances will dictate the actual design tool of choice to be used. This may be Aviva or Intergraph, or possibly something as of yet unknown. The Aviva and Intergraph tools should be presented as the preferred options. This presentation toolkit is Intergraph based. I explain the reason for supporting both platforms. These might be local market force, customer specifications, and availability of local resources. Reference is made to the procedures in the AMEC document library, and a link to this should be demonstrated live at this point. We review a software roadmap for a typical project and the interfaces between all of the applications, and wrap up this section with some of the key responsibilities of the lead, including the time required for project setup, together with model and drawing content. It is important to stress that the lead has responsibility for quality. At this point, the presentation switches to how we are applying data-centric applications and what we are developing. There is a practical for the attendees to work with their immediate neighbours in small groups to identify what data might be exchanged between their disciplines, who the owner of the data is, and how the ownership might change over the project lifecycle. The ultimate vision is to achieve a single point of entry for data and pass the data forward to other disciplines and tools as required. I step through the data correlation between the application tools. This is being used as a quality measure to demonstrate the discrepancies that can and do occur when data are entered by many people in many disciplines using multiple applications. Having identified the differences, the next step for engineering systems is to provide notification of change. So for example, when something on a P&ID is changed and reissued, the disciplines that are impacted are notified of the change. The basis for this is the engineering workflow, and the corresponding workflow diagram should be presented. Moving towards the vision, the next step, again for engineering systems, would be to automate the transfer of change. And this is presented as a gated process to ensure engineering control is maintained. With so much emphasis being on the change from document focus to a data-centric focus, our handover to the customer will transition to a database handover. We are already seeing this with some customers where specific databases form part of the project handover, or where the customer is hosting the design tool and already has the data in their office. For instrumentation, the database is already being used for plant operations. Such a move from document to data-centric concludes the engineering systems presentation.